Everyone, warm welcome to all of you and also Professor Kim to Asian Polymer Association Sustainability Forum, a forum established recently with the vision to bring together scientists and technologists working on sustainable science and technology of materials for providing solution to different challenges faced by society. Today, it is a great pleasure for me to introduce our distinguished speaker, Professor Kim. Professor Kim obtained PhD in Chemical Engineering from University of Houston, USA, and is currently serving as a professor in the Department of Environmental Engineering and Energy, and also in the Department of Energy Science and Technology. He is also director of Environmental Waste Recycle Institute and Carbon Capture and Storage Innovation Technology Center. Professor Kim is very active to pursue his research interests as evidence from more than 200 publications and 30 patents. Professor Kim will share his expert views and research work on technical feasibility and challenges in upcycling of waste polymer, a subject of very high relevance for polymer sustainability. Let's hear expert talk of Professor Kim, who is also Chief Executive Member of APA Sustainability Forum. Over to Professor Kim.
Hello, everybody. Can you see my slide?
Yeah, please proceed, sir. Professor Kim, we can see your slide. Yeah.
Okay. Thank you for your valuable introduction. My talk is much related to technical parts a little bit. Yeah, but last time Professor Ramakrishna overviewed the global things and overall pictures of sustainable polymer metals thoroughly. So I don't want to maybe just help some parts a little bit related to technical parts. So title is Technical Feasibility and Challenges related to recycle, upcycle of waste polymers. Basically, main source of waste polymers are like that. From packaging. So packaging portion is very high because very related to our lives. So and then second one is miscellaneous metals and 22%, and the other one is building and construction materials based polymers are there. So usually food packaging or building or basically number of things, number of polymer metals related to our human beings' lives, and so other special ones from electrical, electronic, or automotive things and other things. So, but anyway, I should emphasize one thing. Basically, we are getting much troubles from waste polymers, but basically I don't think so. Because some merits we can find very big merits from waste polymers, because I should tell something later, but anyway, we know that the many different types of polymers, right? So we are familiar with many things, and those are PET, PE, PVC, or NEPP, PS, and so many different types of polymers are available. So I wanted to focus on the availability and abundance. So anyway, also we can distinguish that some usage of polymers, but we can, depending on the our human beings' lives, we can distinguish some polymers, but technical parts we don't need to distinguish. But anyway, I hope to emphasize some points. One is we can, this is a big diagram because as you know that in this figure, we can see some progressive increase of waste polymers in some region by region. So, and usually in this figure that Middle East and Africa or some Asian area, is some polymer waste polymers increased more. So, and then we also, as you know, that develop some North America, Europe parts are basically stably managed like that, relatively year by year afterwards. So the big burdens from Asian countries and Africa and some developing countries. So we should focus on the use of waste polymers in some Asian countries or developing countries. Anyway, this is a typical figure from the conventional waste management system. As you know that we have even polymer, including polymers or any waste, solid waste. Usually, as you know that we are focusing on incineration and then the filling to treat that waste disposal, right? That in the part, but by the conventional method, we are focusing on 4R technologies. This is recovery, recycling, reuse, and reduction, right? So we are focusing on 4R technologies, but in these days, we should focus on more. So otherwise, hopeless. So yeah, of course, that we should keep 4R technologies, of course, but in addition to 4R technologies, we should emphasize and we should focus on upcycling for more valuable technology for valuable products. So in that point that yeah, I just classify two portions, two main directions in technical feasibility and challenges about waste polymers. So first one, I just put the title, wow, waste polymers. You can say, wow, maybe no. So because this is waste, but promising point is compared with the normal polymer, right? Initial raw material polymers. This is cheap, right? Compared with the new polymers, but also these waste polymers are abundant. Wow! So why not? We can tackle, right, to attack some technologies, how to use that cheaper and abundant raw materials. how you can consider waste polymers as a very, very valuable raw materials, right? In that point, that's the special direction we can find, right? So additional one is, yeah, of course, that we should develop, especially develop new polymers, biodegradable or maybe sustainable new polymers, right? Not like the conventional polymers. So that's the new direction. But this one is still we should promote more. So, but one big point is we have waste polymers. This is new biopolymers are not yet available yet. This is we are promoting more, and but this one is available. So we can say wow. Okay. So anyway, I can classify. This is from textbook everywhere. We can divide this kind of technologies. Okay, primary, secondary, tertiary, quaternary, right? Like that, 4 kinds like that. So primary is maybe just a reuse, right? Clean and reuse like that, right? Secondary, secondary. So I should briefly point out 4 kinds of technologies, right? As you know that the we have this is waste polymers, right? Polymers. Wow. But this one can be recycled, right? In this case, that I just put the same terminology, recycling. So 4 kinds of recycling, right? So so this one can be easily we can recycle and we can use. And but second step is I'll tell you that what's the difference between among that 4 kinds. So that let me see. Secondary is you see you can follow this way and then mechanical, right? Mechanical points, right? So and then very simple. Simply we can treat something, right? This is mechanical. So and then after that we can crush and we can do a lot of things, right? So and then using this and then we can maybe use the reuse or recover or whatever. So I'll show you one example based on my all the time project. So the one company just collect the wallpaper, right? So in India, in Korea, even especially we are using wallpaper everywhere. So when we clean and we can usually wall part that we didn't paint. Usually in big building, we can paint, right? But in usually maybe in my house, right? Even we are using not paint. We are using the wallpaper. So wallpaper is very, very special. So and decorated and coated. So that means it's simply little different, but basically background is substrate is paper. But but on the paper, especially some special polymers coated. So so after using, and then sometimes there's the waste, and then we need to separate, right? So there are many ways, but typically people, some companies are using some special solvent to separate, but that's another matter. So even everywhere to separate the paper and polymer, there are many techniques, right? Even there is very, very crude level of technology, but still many technologies are needed. So anyway, one company asked me to help their business, and then we together develop some processes, and then so I'll show you something here. Very simple. So basically, wallpaper stuff is collected and then moving here, and then this is a crusher part, and then crush, and then crusher part is here. Then this one is we can use that the special process, and then put them all that into that process. That process is I call just centrifuge, right? Centrifuge type, special centrifuge. Inside some special maybe tools are there. So and then but centrifuge means that the gas solid separator, right? As you know. So we use that, and then finally we got a sample, right? Powder. This is powder. Two kinds of powder is separated. One is paper. One is PVC. Okay, for example. So this is a PVC powder, and this is collected paper stuff here. Is separated, right? So and then yeah, of course, the PVC not very much pure. Roughly 90 to 93% like this, like the PVC. But this one, it can be used for many areas. So and then, but this one is very, very cheap. Okay, compared with the new one. So this one is 30% of so very cheaply we can use. I mentioned that so this company got much PVC or any polymer or maybe recycled PVC powders, and using this this kind of PVC powder can be used for the to make that the pipes and many maybe additionally use that some papers or something. But anyway, the point is in Korea, this one cannot be used for making pipes and things because by the law. But in African countries, this kind of thing can be used for making the pipes and things. So many African countries, some companies visited this company to use this kind of thing. Anyway, so another one is this is from multi-layer plastic packaging materials here. This case that especially separate the layer by layer in solvent, different types of solvent, and then some steps very useful to separate all. This is maybe published in Science Advances, not my paper, but yeah, this is very based on the very conventional way, but apply the conventional technologies in high-tech materials. So there are many strategies how to treat that the waste polymers, but this is normally well known. And also last week the Ramakrishna, that professor, the overview, that the overall picture of strategies, so very, very helpful. And I should mention that the tertiary waste, there are many ways, but the chemical way and some are pyrolysis way, and number of routes are there. So main thing is here summarily or chemically, like that. So this is many ways there. So some examples there, but in the case many factors there. So I should mention one thing, because this kind of technologies are not very much high level. As we know, that's normal based technologies, right? Based on that, we can find many new maybe smart ideas needed. So in that case, usually I should emphasize one thing is especially catalyst, right? To promote more, right? So catalyst things, and how to control the summer condition or not common condition, and then we can do a lot of things. But anyway, so in one way is PP case that we can functionalize, right, by the chemical route, and then we can promote many different types of reactions. In the case that to promote those, and then we need some special catalyst, right? So we are focusing catalyst works studies very conventional, right? So we can do a lot of things, right? Yeah. So and also another way is carbonization. Using carbonization, carbon is very nowadays necessary in many areas. So we can come up with very different types of carbons based on waste polymers. So and also, as you know, that by the gasification or something, and then we can make more. But anyway, so some examples are like this, and then depending on some summer conditions, and then we can make different types of carbons like this. So so why not? Yeah, we can do number of things, right? So based on the waste polymer, not very much special. I think that we can just imagine, and then we can get many fancy, expensive or valuable materials. Anyway, so another thing is I showed that this one is PET. Using PET, also we can make many different types of chemicals also, right? Like that. So I should skip this part, and then yeah, like that. So and then after that, the waste polymers we can finally get real expensive, right? We can get more money, right? So we can provide some technologies to the companies, and then company can get more benefits. Anyway, so oh yeah, this is not only chemical route, but I'm not very familiar with some biological way, but we can use an enzyme or in microorganism to convert that waste polymers into valuable chemicals. Also, so and as you know that the novel catalysts are maybe needed, but catalyst. So basically, by the routine ways, we can develop many different types of catalysts. So and then I just show that the very routine ways to develop new catalysts like this. So anyway, finally, quaternary part. This is a free option. I guess that to imagine something, and then we can come up with very different ways. So how to how to change the status of waste polymers into very special one, right? So in that part. So wow, that waste polymers can be converted into many different types of materials in 3D printing or some lubricant or even electric batteries or some energy storage materials and polymer electrolyte, and then some waste polymer can be changed, right? Transformed into the valuable thing, right? So many areas available. So in my lab or in my institute is I call that EWRI, Environmental Waste Recycling Institute. This one is set up last year. I got a 9-year project. It's supported by Ministry of Education in Korea. So I launched, and now roughly 7 PhDs and 20 students are working here. So most of one half of the people, Indian people, students, PhDs. So we are using some waste material also, and some based on some ideas, and we are dealing with many different types of materials. Okay, so come up with based on the polymers and some inorganic materials, so related to environmental, energy, fusion technologies. So here are some membranes or even smart windows, and then some based on the biorefinery, we can come up with many things. So some using biomass, but using also biopolymers or polymers. So one example is that I just emphasize one thing, that there one is waste polymer, but not waste polymer. Waste polymer status will be changed into very high level, high smart things. We cannot find the portion of waste. So we should expect, right? So that's the point, right? So anyway, some we can combine some waste things and special adding some special functionalities stuff, and then that films can be maybe transformed into the very valuable film, right? So we can add some, of course, we should add some additive something, and then we can use. So in this case, that we are this is based on our recent paper. So we can come up with some, we can develop some special polyiers, and then we combine with the films, and then we can make that smart window purpose film. So color changing with the photo intensity, or also some we can add some electro response functionality also. So, and then depending on some condition and that some stimuli will make some color change, and then we can detect like that. So number of purposes. So waste material can be transformed into something. Okay. Yeah. So next part is biopolymers. This is a new field, but maybe I just to show a little bit. So we imagine some special biopolymer, not like the synthetic polymers from based on the crude oil. Okay, so so this one is a new field. Yeah, of course that long time ago, many people imagined special bio-based polymers, but still ongoing project and technical parts. So so I compared, as you know, that this biocompatible. Some most important part is biodegradable and compatible with also synthetic polymers, because this one is used still. So carbon neutral. Some issues are there. So last time the Ramakrishna professor that he mentioned many things. So it took huge picture of that sustainable polymers, and so we should essentially we just extract one by one, and then we can make some parts. We can tackle some technical parts for that. So anyway, so the point is this: we are using many polymers. This is like a synthetic polymer, right? But this kind of things we needed. So based on the bio sources, we can maybe we can make some something new polymers, biopolymers, like the synthetic polymers. That's the point. So this part is not easy to do it. Yeah, but yeah, we many updated works are available. But anyway, I point out. So anyway, I'll skip this. Okay, this. Yeah. So finally, the nowadays in Korea, that Samsung and the LG company, they focusing on some sustainable materials and things. So those companies are just invent much money to hold that some maybe waste polymer, some environmental companies. So nowadays many fluctuating maybe strategy for the future business. But anyway, last year the LG chemical company announced that world first biodegradable plastic with identical properties, functions. It may be that the I'm not sure that the LG company has 25 patents for biodegradable polymer plastic. So, and then proven recently, and they mentioned that more than 90% degradable within 3 months, 4 months, like that. And then they imagine more, so like that. And then LG company will maybe imagine that 2 or 5 that maybe commercialize, right? To produce that kind of polymers, and then maybe will be extended more. So in my talk, I here's my maybe in Jeju conference that we took the picture with my people, right? So, and then so you can find your friend there maybe. So anyway, I hope to emphasize, right? Waste polymers are not waste. I think that that's the very, very valuable source of our living. Okay, that's the point. Okay, so we just maybe change our mind, right, to look at the waste polymer. That's it. My talk is done. Thank you.
Okay. So thank you, Professor Kim. A wonderful talk, I would say, in the field of waste polymer management. I like your statement that waste polymers are not the waste. These are the very interesting, very important materials. It's true that we are going to develop so many things out of these waste, so-called waste materials. So, in this talk, I would like if there are any questions from anyone, probably that would be interesting to answer.
Professor Bhuvnesh, let me pick up a few questions which have come for Professor Kim. The one question is, what is the percentage of waste generated in the world which are upcycled? Any idea?
Wallpaper, you mean?
I mean, how much percentage of waste is converted into upcycled product? You have mentioned upcycle.
Upcycle, yeah, upcycle. I think that most of the point is we didn't, right? We didn't imagine the upcycle, right? So far that's the waste. So we just reuse and recycle a little bit and then reuse, and that's it. We should change some mind, right? Because that's my point. So we can imagine how to get the maybe valuable thing from the waste, right? And then there are many ways. There are many ways. So I don't say that that's a smart. No, not smart. Based on our routine, okay, conventional background, we can tackle to convert that waste into very valuable thing. Okay, so we should do little one more step. We should think about, right, how to upcycle, right? Yeah. So
okay.
I mean percentage.
Yes.
Percentage is as you want, right? You can make more, right? Yeah.
Okay. Another question is, you have mentioned about polyolefin converting into wax and then into the monomers. Do you have any suggestion for only converting the polyolefin into wax rather than converting into monomers?
Basically, I have no idea because I didn't do right such a work, right? Long time ago, the major companies, right? Major companies in Korea, that LG, SK, or many Samsung is maybe not very much interested in the chemicals. Basically, with some battery or some part, but usually SK company, or in Korea the SK and the LG, two companies, major companies, considering the chemicals. So so polymers, right? Polymers, that usually LG. So they are very much concerned about how to reform or maybe transform, right? Transform their materials, right, into wax or any. So, but they don't want to make the reuse, right? They are focusing is to make that new, maybe how to convert them into valuable chemicals more, right? But I discussed with them that long time ago, but I didn't get any project with them, so I didn't start yet.
Okay.
I'm sorry.
Okay, one more question. I think two question. I will take it. There are many questions which are coming, but I will pick up two more questions. What is your thought on thermoset composites management? The recycling of thermosets composites, not the plastic composite, thermosets, epoxies and other composites. Any thought or any suggestions? Yeah.
No, I am not the maybe polymer engineering, polymer chemistry person. Okay, so I'm not a professional in those parts. Yeah, but I cannot answer that one. Yeah. So, but yeah, but maybe. In my major concern is to how to use that some maybe real waste polymer or plastics, right? And then nobody concerned about some materials, and then that I can take, and then maybe we can discuss, and then we can come up with some new technology to tackle that one, right? So, but some setting things are a little bit hard to handle. Yeah, some not like a soft one, but yeah. But anyway, I'm sorry that I have no idea. Yeah.
And the last question I will pick up because of the time constraint. You have talked about biopolymers.
No.
How the biopolymers is going to compete with the synthetic commodity polymer in different sectors from the cost point of view? Any idea?
Not easy, but I basically 7 years ago, I had joined that into one project, and then in that case, as you know that compare with crude oil refinery, right? So some big trends is based on the biomass using the biorefinery, okay, route, right? So, and then the two routes, one is bio route and the chemical route. Yeah, but usually we are starting with cellulose, okay, because biomass, usually biomass is the main source is cellulose and maybe three components. So, but usually cellulose is a good source. So cellulose can be converted into sugar, right? So, and then sugar can be transformed into many diverse chemicals useful. So in that case, that we can come up with, right, from the biomass things, and we can find some special polymers, not like not exactly not exact that, for example, PT or something, not like, but properties, right? Property or some functionality point of view. So we can find many different types of polymer things, right? So and then we can compete and we can find some special things, and then as the better, not better, basically maybe reasonable substitute for the synthetic polymers, we can try, and then we can modify more based on that. So at the time, one company that the CJ company is maybe related to sugar and some other parts for food. That company is concerned about those. So and then invested much price money, and then they got some biopolymers, right? Maybe so using those, and then even they hope to make some clothes and other some plastic packaging materials, but not yet.
Okay.
Yeah.
Okay.
So not easy. Yeah.
Okay. So Professor Kim, we have many questions which are coming. We will forward to you. You can respond to them for their queries. And now I again ask Professor Bhuvnesh to take over.
Yeah, so thank you, Professor Dr. Virendra Gupta. I mean, what I would like to say is that this forum, which was created as the APA Sustainability Forum, this forum has been a wonderful forum within the domain of APA. And what I see is that this Asian Polymer Station is really serving a very good mandate as far as the science and technology of polymers is concerned. And by using the platform of this sustainability forum, where Dr. Gupta is coordinating it, and you, Professor Kim, and other four more people are the associate members of it. So with the support of all of you, I'm sure that this sustainability forum is going to rise more and more. And we are going to do many more such activities where especially our young generation is going to benefit it, because what is important for our country and for at the international level is that our student force, our researchers, young budding scientists, they should be given more and more knowledge about the polymeric materials and their wide range of applications. And especially whole world is looking for sustainability. So I think these talks, as you have given today, a wonderful talk where you could compare the synthetic polymers and biopolymers, their applications, and instead of calling them waste polymers, we could call them smart polymers or innovative materials, whatever you call them. Certainly, you can modify them accordingly. So, with these words, I like to thank all of you, the team of Professor Gupta and Professor Kim and Professor Shantanu Bhaumik, Viplo, and Sriram Ramakrishna, all these people who have created this domain under the umbrella of APA to make it sustainable. And we look forward to hear you again, at some other platform. So from my side, greetings to you all.
Yeah.
And this is the end of all the talks which we have undertaken in the last 1 month. So thank you so much, and of appreciation.
Thanks, Professor Bhuvnesh, for your very kind words, and also which will encourage APA Sustainability Forum to come out with different lecture series and webinars and other to continue to bring ignition in the mind of the young scientists and technologists. Dear friends, the talk of Professor Kim was the last talk of the 4 lecture series on materials covering circularity and sustainability. In this 4 lecture series, we have heard eminent scientists, technologists, expert. In the beginning, Professor Bimblesh on the sustainable polymer for energy sector, Professor Santanu Bhomik on polymer composites from the waste. Then we got a deep insight on linkages between circularity and sustainability of polymers and brought out different dimensions by Professor Sriram Ramakrishna. And lastly, in this last talk, Professor Kim has given a deep technical insights of the technical challenges and possible solution for upscaling the polymer waste. So we thank all our eminent speakers and distinguished speakers, as well as all the participants who have taken valuable time taken out and attending this 4 lecture series. And the interaction was quite interesting. I hope not only we have learned, but I hope all the participants have learned the different aspects on sustainability related to plastic material. This was our first lecture series, and we will be in coming days coming it out with different either the lecture series or webinars or conference and other on a one day to cover different sustainability aspects of plastics and materials. Until then, goodbye to all and be safe. And once again, thank you very much for all of you, and also thank to all our eminent speakers, and today to Professor Bhuvnesh and also Professor K. So, thanks a lot.
Thank you. Thank you so much for the wonderful evening. Thank you. Okay.
Yeah, thanks.
Bye.
Bye.
Bye.